On October 29, 2024, China announced that the Shenzhou 19 manned spaceflight mission will be launched at 4:27 on October 30th. The astronaut crew consists of Chai Shuji, Song Lingdong, and Wang Haoze. Among them, Wang Haoze, China's first female aerospace flight engineer, has received extensive attention according to official disclosures and publicly available information retrieved from the internet. Wang Haoze previously worked in the Aerospace Power Research and Development Department of China, Aerospace Science and Technology Corporation. In September 2020, she was selected as a member of the third batch of Chinese astronauts. During her tenure in the corporation, she was deeply involved in the research and development of future aerospace power systems, represented by nuclear thermal engines, and published several papers. Nuclear-powered engines, including nuclear thermal engines, are a generation-ahead power system compared to current chemical-powered rocket engines. Although China has not yet announced the specific mission of the Shenzhou 19 crew, considering that China follows the principle of making the best use of each person's abilities when selecting and dispatching astronauts, Wang Haoze's journey into space has brought room for imagination. Perhaps domestic nuclear-powered aerospace engines are already ready for some tests and verification in the space environment. Even if it's just preliminary research, nuclear-powered engines the fast-forward button for human exploration of other planets. When it comes to exploring other planets such as Mars, people may think of the recently famous SpaceX Starship giant rocket. According to Elon Musk, the boss of SpaceX, the ultimate goal of this rocket is to establish a fully functional and self-sufficient city on Mars, making humans a multi-planetary species. The Starship already represents the highest level of human rockets at present and even in the next 10 years or more. However, as a spacecraft using methane and oxygen as fuel, its performance is also limited by the weak ceiling of chemical reaction energy. Taking the journey from the Earth to Mars as an example, the spacecraft can only depart during the window that appears once every 26 months when the positions of the Earth and Mars meet the requirements of the Hohmann transfer orbit. Otherwise, a large amount of fuel will be wasted during the journey, resulting in a sharp reduction in the payload and loss of practical value. Similarly, the return journey also has to wait for the window period. The round-trip time between the Earth and Mars is as long as several years. Nuclear-powered engines generate thrust by accelerating gas such as hydrogen with high temperature, generated by nuclear reactions, or by generating electricity with high temperature and then ejecting fuel with an electric field. The former is the nuclear thermal engine mentioned in Wang Haoze's paper, and the latter is the nuclear electric engine. The difference in difficulty between the two is not too large, and they have complementary advantages. The nuclear thermal engine has sufficient thrust and strong explosive power, suitable for time-sensitive personnel transportation missions. The nuclear electric engine is relatively gentle, but has high fuel utilization efficiency, suitable for transporting large volume cargo. Whether it's thrust, speed, or fuel utilization rate and other key indicators, nuclear-powered engines far surpass chemical-powered engines. According to estimates, a spacecraft using a nuclear-powered engine can complete a round trip between the Earth and Mars in about 90 days at the shortest. This time is even only half of the duty period of the Chinese space station crew. Humans realized the huge advantages of nuclear-powered aerospace engines as early as the 1960s and carried out certain explorations. However, due to the limited level of nuclear physics, materials, control, electronics, radiation management, protection, space science, and engineering at that time, no successful results were achieved. Now, when relevant research is restarted, the conditions are more mature. On the one hand, significant progress has been made in the above-mentioned disciplines. On the other hand, It also benefits from the emergence of new production relations and productivity represented by commercial spaceflight, which has greatly reduced the cost of entering space for relevant scientific research, tests, construction, and operation. After all, considering safety and construction difficulty, the spaceport for constructing and operating nuclear-powered spacecraft is preferably set in space, and personnel and cargo are still transported between the Earth and space by traditional chemical-powered spacecraft. Therefore, although large capacity, low-cost commercial traditional rockets are outperformed by nuclear-powered spacecraft in performance, they are still indispensable symbiotic products. Speaking of commercial spaceflight, another piece of news from the Shenzhou 19 mission press conference is worth paying attention to. It represents a very direct and down-to-earth measure of China to support commercial spaceflight. Referencing the NASA model of supporting SpaceX to cultivate the vital forces of China's commercial spaceflight, the press conference revealed, in order to further reduce the cost of transporting cargo to the Chinese space station, enhance the flexibility of upward cargo transportation, and explore the development of the commercial spaceflight model. Last year, the China Manned Space Agency released a solicitation announcement for the overall plan of the space station's low-cost cargo transportation system. 4 out of 10 plans were selected to enter the detailed design phase of the plan after the second round of selection. Finally, the Lingzhou cargo spacecraft plan of the Innovation Academy for Microsatellites of the Chinese Academy of Sciences, abbreviated as CAS, and the long cargo spaceplane plan of the Chengdu Aircraft Design and Research Institute of the Aviation Industry Corporation of China, abbreviated as AVIC. Chengdu 1. Obtaining contracts for the engineering flight verification phase. The solicitation of the overall plan for the space station's low-cost cargo transportation system is regarded by the outside world as China's measure that parallels the COTS project, which was praised as a stroke of genius by NASA 20 years ago when it supported the startup SpaceX COTS, whose full name is Commercial Orbital Transportation Services, is a project launched by NASA around 2005, aiming to maintain the United States transportation capacity to and from the International Space Station after the Space Shuttle retired, different from the cost-plus contracts that were previously distributed to industry giants such as Boeing and Lockheed Martin, which guaranteed profits regardless of the situation. COTS adopted fixed-amount contracts. 1. The finalists have the opportunity to obtain generous but not excessive grants. 2. The funds are dispersed one by one upon completion of dozens of nodes agreed upon by both parties. 3. The research results belong to the finalists and can be used for other profit-making purposes. But the finalists must provide NASA with several services demonstrations as agreed for. NASA can make additional purchases later. It can be seen that COTS has achieved a good balance in terms of enterprise incentives, progress management, and cost control. It was precisely with this support from NASA that SpaceX, which hadn't even achieved orbit at that time, efficiently developed the now famous Falcon 9 rocket and Dragon spacecraft in just a few years. In fact, SpaceX was not the only finalist of COTS. Another company that completed the project, Orbital Sciences, also developed the Antares rocket Cygnus spacecraft combination and also undertook the transportation task to the International Space Station with relatively low cost and high efficiency. However, compared with the great success of SpaceX, the comparative success of Orbital Sciences seems to be little known. Two successful companies at one time illustrate the superiority of the new system and also make the shortlisted list announced by China today widely watched according to the project plan. The CAS and AVIC Chengdu are responsible for leading the proposal of their respective overall plans, and the specific engineering practice will be completed in an open and multi-party, collaborative manner. For example, the rockets responsible for carrying the spacecraft and spaceplane are expected to come from emerging private spaceflight enterprises. Currently, to rocket companies. CAS Space and iSpace have revealed that they are participating in the space station's low-cost transportation project. CAS Space has even announced that the Legion 2 rocket, which is under development, will conduct spacecraft verification missions during its first flight in 2025. It is also understood that the shortlisted spacecraft and spaceplane can be matched with multiple types of rockets. Whether there will be new launch contract disclosures later, let's wait and see. China officially announces the lunar landing mission and astronauts are in place. The personnel, location, and time of China's lunar landing mission are all on the agenda. These 10 reserve astronauts will launch a manned spacecraft at the Wenchang launch site and achieve manned lunar landing before 2030. It should be emphasized that the so-called lunar landing mission here is not as simple as just a visit. Instead, it is planned to establish a scientific research and experimental station on the moon and conduct a series of scientific research and technical tests. These researches will cover multiple fields such as space life science, microgravity basic physics, and space materials science. That is to say, what are now only PPTs and movie-like lunar bases are very likely to become a reality by 2030. The difficulty can be imagined. The Chinese aerospace personnel have never fought unprepared battles. Since it has been officially announced, they are holding the certainty of victory. Just as China once built its own space station from scratch, lunar landing is just a matter of time. Academician Wu Weiren, the chief designer of China's lunar exploration project, said with full confidence that before 2030, Chinese footprints will surely be on the moon. This is indeed the case. As early as 2004, China has been preparing for the manned lunar landing plan. It officially approved the project establishment of the Lunar Orbiting Exploration Project and formulated a 3-stage policy of unmanned lunar exploration, manned lunar landing, and establishing a lunar base since October 24, 2007. The Chang'e series of lunar probes, shouldering the important tasks of orbiting the moon, exploring the moon, and landing on the moon, have started their journey to the moon. In 2020, the Chang'e 5 probe successfully returned with lunar soil, making China the third country to achieve lunar sampling and return after the United States and the Soviet Union next. The goal of China's manned lunar landing project is to continue to promote the specific tasks of the fourth phase of the Chang'e lunar exploration project, including the sampling and return of the far side of the moon by Chang'e 6, the simulated manned lunar landing by Chang'e 7, and the scientific exploration of the polar regions of the moon by Chang'e 8. However, many people may ask, why are we still so persistent in going to the moon in the 21st century? First, there are still a large number of unsolved mysteries on the moon. Surface resources such as rare substances like helium-3 are widely regarded as ideal fuels for future nuclear fusion. The establishment of a lunar base will provide an ideal experimental site for humans. Second, as the first stop for humans to explore space, the moon is very likely to become an outpost for human deep space exploration. Future space explorations such as Mars missions can use the moon as a springboard. Third, for China, the success of manned lunar landing will be an excellent opportunity to showcase the country's aerospace strength. Previously, the West always questioned, can the Chinese land on the moon? Now, their tone has changed to surprise. How can China land on the moon like this? When Chinese astronauts set foot on the moon for the first time, it will undoubtedly be a historic moment. Interestingly, at the press conference of the Shenzhou 19 manned spaceflight mission, a reporter asked, to American astronauts on the International Space Station, whose original business trip of 8 days was postponed, what if the Chinese space station encounters a similar situation? In response, the spokesman of China's manned spaceflight project gave a sarcastic response to the United States. We appreciate that NASA attaches great importance to the safety of astronauts. At the same time, we also wish the two astronauts a safe return. I wonder what the United States is thinking at this moment. A world's strongest aerospace power that has landed on the moon many times now has great difficulties and struggles in lunar landing. What on earth is the problem?